Hello, Algebra 1. We're in 9.2. I'm working from two papers. One is notes from 9.2. The other one is the vocabulary we filled in yesterday up to 8. And today we can do a couple more on that paper. So let's start off with just an idea. If you have an equation that has two variables, that's new to our life. Most of our year we've solved equations that have one variable, but there's a lot of equations that have two variables. If you have equations with two variables, there's an infinite number of solutions. Infinite meaning so many you can't count them. The only way you can describe all of those solutions is by making a thing called a graph. And I will show you what I mean here by doing this problem, which would be more fun if people were here with me. But if people were here with me, I would ask you to name me some numbers that add up to 5. So people would say stuff like 2 plus 3 makes 5. And somebody else would say 1 plus 4 makes 5. Somebody might at some point say, is it the same or different if I said 3 plus 2? And I would say that's different. 3 plus 2 is a different ordered pair, to use a word from yesterday. The ordered pairs, the order matters. So then somebody might say, hey, 4 with 1. Somebody else might say 5 with 0, or 0 with 5. And then sometimes after we do those, there's like a hesitation. People are like, I think we're out. And then somebody will come up with an idea, or I'll prod an idea by saying, how about if you got like a negative number involved? And they'd say, oh yeah, maybe like -1 with positive 6, or positive 6 with -1. Or somebody might say, hey, we could do like decimals, 3.5 and 1.5, or do that backward. And soon you realize there's no end to this. Somebody might even suggest eventually, as sort of people get sometimes silly, they might say, let's do 1,000,000 paired up with negative 999,995. Yeah, that's true. Okay, there would be no end to these. Okay, yesterday what we learned is that we could take coordinates, ordered pairs, and make dots on a graph. So let's do some of that. So 2, 3 would go over 2 and up 3. 1, 4 would be over 1 and up 4. 3, 2 is over 3, up 2. We're over 4, up 1. Over 5, but not up at all. Not right or left, going up 5 is what 0, 5 is. -1, 6 would be over 1, up 6. 6, -1 is over 6, down 1. And you're probably sensing a trend here a long time ago. Okay, 3.5, 1.5 would be over 3.5 squares, up 1.5 squares. 1.5, 3.5 would go over 1.5 and up 3.5. And you probably are realizing now, especially if I had graph paper, anything that you could name me would end up in this line. And anything on this line would be something that you could name me. So if I drew a line, and that's a little bit off kilter, but if I drew a line that connected all those dots, every ordered pair we could create from our mind would be on that line. And again, everything on the line would be an ordered pair. If we could graph 1,000,000 and -999,995, if I had the ability to go over 1,000,000 and down almost 1,000,000, I'd be somewhere well underground somewhere, digging a tunnel, I suppose. But it would be at the end of that line. Wherever that line is leading me underground, if I had the patience and space and shovel to go 1,000,000 spaces, that's where it would go. You can also see just from the picture here, if I were over 7, I'd be down 2. Like that, this point right here would be over 7, down 2, that would be on the line. That would be another answer, because 7 plus -2 is 5. That's what we're going to try to do in this chapter from here forward is, we'll have an equation situation where you can't get one answer, It has so many answers, you can't even describe them all. It would take you literally an eternity to do them all. But a graph is going to be a way to show that we can do that. The little arrows on my line are telling me those go forever in both directions, and we're covered. For the most part, well, never again, are we going to try to generate, like, what do we do, 12 answers there? We're not going to try to generate 12 answers to do a line. 2 or 3 dots should do it. Once you have 2 or 3 dots and you can connect them, you're in pretty good shape. So the first kind of graphing we're going to do is going to involve a special thing called intercepts. And before I erase this, I'll say that this point right here is an example of an intercept. An intercept is a point where you're crossing one of the axes. This is the x-intercept because it's where our line touched the x-axis. That was the one that had a coordinate of 0 for the y. This point right here is called the y-intercept because it's where it touches the y-axis. The y-axis, anytime you touch the y-axis, the x's number is 0. So we're going to use those intercepts in some of the homework tonight because since 0 is involved, they're like easier things to deal with. And if we can figure out what the 2 intercepts are, just play connect the dots on the 2 intercepts, everything else will fall in line, no pun intended. But everything is going to have to be a straight line today when we graph. But the intercepts are those kind of points. I'm going to clear this out to make some space because in a minute I am going to need this space for some future problems. So now I'm looking at the notes paper. So we can now do number 9. Number 9 says, what does a graph do? And my answer is that it shows you all of the solutions of an equation. For number 10, standard form is on the notes that I already wrote with my hand. Standard form is going to be a good thing to know about. Standard form's equation is this, with the additional detail that A, B, and C have to be integers, which means no fractions, no decimals allowed. Integers are like my number line numbers. Negatives are okay, zeros are okay, positives are okay, but it has to be these non-decimal, non-fraction, number line-y kind of numbers. Standard form means x and y are on the side, and the number gets out of the way with no fractions involved. If you see an equation in standard form, that's often a cue that intercepts are going to be a good way to do that problem, but I didn't say always. It's not always, but often a good way to do the problem. So here's a problem that I can do intercepts for. What's a good thing to look for is if both of the numbers with the variables can go into the other number, that's a good problem to try to find these intercepts. Again, intercepts mean one or the other of the numbers is 0. So if I want to seek out this answer, this means that x is 0 because x is always first. If x is 0, I'm just going to cover up the x part of the problem with my hand. And I'm going to focus on the y part of the problem. If 4y equals 12, we can solve that by doing an opposite. Look to divide by 4, and that would reveal a 3. 0, 3 is a point located up 3 relative to where the origin is. For this other intercept, the y being 0, I can just cover up the y stuff with my hand. And I can do an opposite. Divide by 3's to solve for x would give me a 4. 4, 0 is located right here on the x-axis. And then I would just play connect the dots. I should try to remember my arrows there. That line goes forever. I just came up with a way to describe every answer for this problem instead of making a list for all eternity. This problem, it's the same kind of a style of a problem because we're in standard form. X and y are on a side. 5 and 2 both go into 10. That will be a friendly problem for us to do intercepts. In the homework, I think this is the day that I say to ignore the directions. Yes, I do. So there are some problems that are really nicely set up for intercepts, and the directions will say to do it another way, and that's stupid. So we're not going to obey those directions. If the problem is in standard form, meaning x and y on the side, and the numbers go into the other number, do these intercepts. It's way quicker. Just do your own thing following my advice, not following book directions. Okay, well, for this one, if the x is 0, cover up x with your hand. The -2 is still a package there. We would divide by -2 into 10 and get a -5. So if I want to graph that, I would go down 5. For the y being 0, cover up the y's with your hand, and that eliminates the minus when you eliminate the y. If 5x is 10, it has to be a 2. 5 times 2 is the only way to get 10. 2, 0 is located right 2. We play connect the dots, do our arrowheads, and we're good. One more of those, same thing. Again, it's in standard form because x and y are on a side, the number's out of the way. It's cooperative for intercepts because 2 and 3 divide into 24. For an x of 0, cover up x with your hand. Solving for y would get you a -8 because 24 dividing -3 is a -8. If we're eliminating x, we're just solving that simpler equation. For this one, we're eliminating y. So if we solve the problem, 2x equals 24, that would get me a 12. X always goes first. That's the right-left kind of number. So I drew myself sort of a strange XY axis just using the area I needed. But for an x of 12, I go right 12. For this, with a y of -8, I need to go down 8, and then I would just play connect the dots. Using a ruler for this is a really good idea, just to keep things straight. But that'll do about half the homework for you. The question then arises, what if you're not in standard form? Let's see if I have any more answers on here. Okay, so I'm 11 to 14. Let me get you 2 more answers on the 11 to 14 part of this. It says, what 2 choices do you have to graph, and how do those work? So choice 1 would be intercepts, and then the answer for intercepts would be find 2 points that have a coordinate of 0. For intercepts, we want to find 2 different points that have a coordinate of 0. Second choice that we're about to delve into is a thing called tables. So the other answer for 14 is tables. And the how the table works answer is get x or y alone, and then pick 3 numbers for the other variable. Get x or y alone, and then pick 3 numbers for the other variable. So for this, y is alone. I'm going to pick any 3 numbers I want then for x. My tendency is to use 0, 1, and 2, because those are the simplest numbers really that you can usually use in math. And since y is alone, I'm going to pick 0, 1, and 2 for x, and just obey the equation that says take 2 times x. So I'm going to take 2 times the ones that I picked. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. I could have picked anything I wanted for x, but I'm going to pick simple numbers. But I have to do 2 times them for this problem. And then I'm going to imagine these as ordered pairs. 0, 0 is the origin. 1, 2 is over 1 up 2. 2, 4 is over 2 up 4. And since those do line up, I feel very good that that's my line. Let me go to this one. Again, it's y equals, so I'm going to pick numbers for x. 0 is always good. 2/3 times 0 is 0. But I don't want to pick 3 or pick 1 here, because 2/3 times 1 is a fraction, and I'd rather not graph fractions. So I'm going to use 3 because the bottom is 3, and if I take 2/3 times 3, 3 is like it's over 1, I get a nice cancel. 2/3 times 3 is 2. And then for this, I'd either use -3 if you're not afraid of negatives, because you get the same cancel, or use 6 if you're a little bit afraid of negatives, because 2/3 multiplying 6 gets a nice cancel to get you 4. 0, 0 is the origin. 3, 2 is over 3 up 2. 6, 4 would be over 6 up 4. If you had done -3, you'd have gotten -2, which would have been this point, -3, -2. Doesn't matter. You don't need all 4 of those. You just need 3 to be sure that you're in a line. Let me do this one while we're in that same mode. Where again, y equals. So I'll always use 0. But with 5 on the bottom, I think I want to use 5 and 10 to get some nice cancels for my fraction to multiply. Because I'm going to have to do 2/5 times whatever I pick, and then add 4. So 2/5 times 0 is 0, adding 4 is 4. That would be up 4. 2/5 times 5 cancels the 5s to leave the 2, plus 4 is 6. So 5, 6 is over 5 up 6. When 10 cancels 5, it leaves 2. To multiply the 2 to get 4. To add the 4 to get 8. So I'd be at 10, 8. Play a little connect the dots. If you're doing it right, the numbers should form a pattern. That's not accidental. Okay, these are counting by 5s, while those counted by 2s because of the 2/5. These are counting by 3s, while these count by 2s because of the 2/3. That should be happening. That's not an accident. If I cut back over to this, this is different because it's x equals, so the roles have reversed. If it's x equals, I'm going to pick numbers for y. We're going to always pick for the other letter. So I'm always going to use 0. And with 3s, I feel like using 3s and 6s probably. So 1/3 times 0 is 0. Adding 1 is 1. 1/3 times 3 cancels 3s to leave 1. Adding 1 is 2. When 1/3 multiplies 6, that leaves a 2. Plus 1 is 3. So 1, 0 is there. 2, 3 is there. 3, 6 is there. Nice straight line. On we go. The last one in this corner before I take a quick walk back to the left. This is in standard form, but it won't work for intercepts because 3 will not go into 8. Since 3 won't go into 8, I would instead work to try to get the x alone. To get the x alone, we'll do some opposites. If they're adding 3y, I would need to subtract 3y. To get rid of the 2, since they're multiplying 2, I have to divide 2. And then I would go ahead and make my table. Since it's x equals, I need to pick 0 for the y column. And with a fraction, I'll go with 2 and 4. So 0 times anything is 0. 4 minus 0 is 4. And there's a dot going there. If I put in the 2, the 2's cancel. 4 minus 3 is 1. So 1, 2 is here. If 4 goes in, 4 cancels 2, leaving 2. Times 3 is 6. 4 minus 6 is -2. So if I go -2, 4, that's left 2 and up 4. Play connect the dots, go arrows, and then I'll have to take a stop back to the left. Unlike most days where they save the worst for last, they save the easiest for last today. The easiest lines to graph are ones where there's only one variable involved. If you only have one variable involved, you're not going to have any diagonal lines like we have it. Anytime there's both x and y in it, the lines go all diagonal. What we're going to have happen if there's only one variable involved is either a horizontal line or a vertical line. So if I have x equals 2, x has always meant to go right or left. The x-axis is going this way. So if I tell you that x is 2, I need to go over 2, and then just stay there. Okay? This would be a whole collection of points like 2, 1, 2, 2, 2, 3, 2, 4, 2, and literally any number in the universe. Okay, so I need to go over 2, and I could go up 1 or 2 or 3 or 4 or down or up or anywhere I want to go. If I'm doing X's of 2's, I get a whole lot of dots like this. You might want to just memorize for yourself that X equals lines always go vertically. So I had that as the letter A, just to label it, just so I don't get confused later. You could graph a lot of these lines on the same coordinate system. If you're going to do these other problems, they kind of need one coordinate system per line. But if you're going to do some X and Y lines, you could do a whole bunch of them, I think. For Y equals 3, the same thing applies. What we'd be looking for is for the second number to be 3, to go up 3. But whatever this number is, it doesn't really matter. So for Y equals 3, so here's my Y-axis, I go up 3, and I could be here, or I could go this way a little bit, or I could go that way a little bit. It doesn't matter how far I go, right or left. I just need to stay where the Y's are 3. And you might want to just memorize for yourself that the Y lines always just go horizontally. I'll label that one as a B. X equals -4. I'm going to go left 4 from the origin, and then I just have to stay there. And as I said a minute ago, any X equals line is going to go vertical. So there's C. Y equals -5, we go down 5, and just stay there. Any Y equals line with only the letter Y is going to go horizontally. And then if you wanted to play some tic-tac-toe, get a good tic-tac-toe game going in that space. But you could do a lot of those lines in one coordinate system without it overcrowding. Where we are for homework based on this is 378. 378, we are going to ignore their directions. Okay, so in 378, number 1's directions say to make a table. But clearly, those are better to do intercepts. So do not do the table on 1 to 4. Do the intercepts on 1 to 4. All of 1 to 4 are like these, where X and Y are on a side, comfortably dividing into the other number. Find the 0 kind of coordinate pairs. 2 dots, play connect the dots, and that's going to be fine. 5 to 12, they say to make it. They say to find intercepts, and that's not the way to go on a lot of these. 7 and 8, I would do intercepts because they're like these. But I think 5, 6, 9, 10, 11, 12, since they have the one variable alone already, like these were, I think you're better to make a table on 5 and 12. 13 through 16, they down to just one variable per problem, so those are going to be like these on 13 to 16. And then 17 to 20 is kind of a mix. Some of 17 to 20 are friendly for the intercepts system. Some of them, they have a variable alone, so it's friendlier for the table system. But I'm going to say ignore their directions. You just need to graph these lines. Intercepts, if it can work. Table, if it can't. The single letter ones are blended in. About 378, we're 1 to 20. If you have questions, email me. We'll get it another time.